Today I'm building two budget PCs, one on the Intel stack, one on the AMD stack, both under $1,000, and we're gonna see which one is gonna give you more bang for the buck, and we're at Micro Center to do it. Let's go. This is Dan. Dan is gonna be helping us do our builds today. Dan's been on the channel before a couple of times, we know him. Dan, we're gonna be building two machines that are gonna be pretty much the same price. Our budget is $1,000 per machine, but the catch is one is gonna be Intel and one is AMD.
So full team blue versus full team red.
Full team blue versus red, that's right. Let's see the chips. What's with the dark boxes? I haven't seen. Oh, those are the new ones, the Ultras.
The Core Ultras. It's the same core count as the previous generation, minus hyper-threading, and it has an NPU.
I want that.
Of course. Yeah, I think
want
so
that.
too.
All right. So typically what I would say is if you're doing machine learning, you want the bigger chunk of the budget to go to the GPU. But here we're gonna have an overall budget machine, which means you're gonna be wanting to do all sorts of things. So the CPU has to account for a good chunk of that. I'd say probably 25% of the budget. Then we're gonna leave about 40% for that GPU, so you can still do your LLMs and run your image generations. And then we're gonna leave the rest of the budget for the rest of the stuff, hopefully not going over. But if we go over, I don't know, there may be consequences. I don't know, we'll see about that.
Okay, so I'm not ready for push-ups, but if it happens, it happens.
So let's see how we can match up the Intel Core Ultra with the same or similar priced AMD chip.
As we've been doing in the last couple of videos, is take advantage of bundles. Like I know I have a bundle for the Intel Core Ultra 7 at like $450 if we want the integrated graphics.
Okay.
I don't think you really need that though, so we can actually squeeze a little bit less out of it and do the $430 one with the KF. The F doesn't have integrated graphics on the processor. AMD does the same thing now, where some of them have an F on them, but they're just very underwhelming.
Well, if it's F, then it's F, but we want to be F for fair. So if Intel doesn't have an iGPU, then AMD shouldn't have one either.
Okay, I think we could try to make that work too.
Yeah?
So we're gonna be doing a Ryzen 7 and an Intel Core Ultra 7.
Interesting, okay. Well, this is gonna be a fun little race at the end. We'll see. Check out this wall. This is the mother wall, as I like to call it. Look at this. This is insane.
There's a lot more in the back too if you want like the really, really fun overclocker stuff.
I've never been in the back. I don't know if that's a tour we can arrange at one point or another, but maybe that's a secret.
Might have to run that by Mark.
All right, Mark's not here. He's on vacation, but say hi to Mark. So what board can we go with to match the chips that we selected?
Yeah.
And still be kind of equivalent so it doesn't go over budget?
So I want to take advantage of the fact that the Core Ultra bundle gives us the Z890 board from Asus. It'll support the processor natively. You'll get all the lanes you will need for what we're trying to do here.
Nice, let's do that. Well, that's the AMD one, right?
That'd be the Intel one. Z890.
Oh, this is the Intel one.
Yeah,
right.
yeah. A little cheap for anyone building a PC. If you're doing AMD and the motherboard has a Z in it, you're wrong. And if the motherboard has an X in it and you're trying to do Intel, you're wrong.
There's the rules of thumbs right there. I didn't know about that. That's good to know.
As for AMD, we are going to be looking at the B850 Plus. The highest chipset would be an X870, but for our purposes, that is totally unnecessary. So the B850 is a tough board, so it's going to be kind of equivalent to that other board in terms of its tiering. Most important thing for our purposes is that first 16 slot for where you would fit in your graphics card. That's going to be PCIe 5.
Is PCIe 5 also available on the M.2s?
Yes, it is.
All right, let's find the RAM. Wait a minute, what's all this?
That would be our actual RAM cage. We've got major brands like G-Skill, Corsair, Team Group.
Do you have ECC?
We do have ECC.
I may do a build later on with that, so we'll see. That's a Threadripper build. What do you have over here?
So like I said, same speed for both, 6,000.
You mean we don't get the fancy boxes?
I mean, we can if we want to break away from the...
Okay. 6,000 is good enough. How much are these guys?
These on their own, if you're buying them at retail, is $89.99. You're not really getting any savings on the RAM. The RAM is usually not discounted.
Both of these work with Intel and with AMD?
So the Ripjaws is the one that's specially made to work with Intel because it has XMP profile. XMP is Intel's basically overclocking language for memory, and then EXPO is AMD's.
Okay, I'm gonna have to remember that. All right.
For the GPU, I'm thinking the B580 Challenger from ASRock. It's $260, and it's gonna be the same variant, the 9060 XT Challenger from ASRock for the AMD side.
So that's kind of fair, I guess, even though one of them is gonna be $100 more than the other one, right?
So now I'm gonna go to that super secret room that I can't let you into to go grab the graphics cards, and I'll be back.
All right.
You can try to follow me, but once these doors close, you're no longer in.
Oh, damn, it says employees only. Okay,
Yeah.
we can't go in there. All
Too
right.
secret,
All
too
right,
secret.
all right. Speaking of sales, September is actually clearance month at Micro Center, so check it out, go to your local store and get some deals. Their new store in Phoenix is opening up pretty soon. You can sign up for VIP days and receive exclusive access before grand opening and a 128 gigabyte USB thumb drive. Nice. See details below in the description.
Back from the secret room with the stars of our whole
He emerges.
program. 2 Challenger cards, AMD and Intel.
They actually look kind of the same.
Oh yeah.
I'm noticing a slight difference though. This one is 16 gigabytes.
Yes.
And that one is 12. And we'll see how that's gonna affect things when it comes to running LLMs. I think it will affect things quite a bit. But just for giggles, I wanna see if you wanted to swap out that Intel board for an NVIDIA board. Let's see what we can do. Is there a 16 gigabyte NVIDIA board that we can keep us in that price range?
In that price range, the closest graphics card we're gonna have is the 5060 Ti 16 gigabyte. It's gonna be about $450.
Oh.
So that's gonna be almost 200 more than Intel and about $100 more than AMD.
Okay, that's quite a lot of push-ups. I don't know if anybody wants to do 100 extra push-ups today, but
Yeah, no.
definitely not me. So I think we're gonna stick with this one for now. We still need a case, we need fans, we need an SSD. Are we gonna fit?
We may end up being a little over.
If we're over, you're doing push-ups.
Do we really need a case? I don't think we need a case, guys, right? Do you guys think we need a case?
We can hang it up on a tree.
You could.
I think what we're gonna do is skimp out on the really, really nice SSDs right now. And if you wanna see a difference in how SSDs affect this, I have another video on that. I'll link to it down below. However, we're gonna go a little bit cheaper today because once you load your things from the SSD, your models, for example, if you're doing machine learning, then it's gonna go into graphics memory, and that's the most important thing. A lot of these large language models are, well, large.
Yeah.
So you're gonna want to have
Who would have thought?
terabyte at least.
The 990 Evo Plus from Samsung is $65.
What?
So
For
then-
1 terabyte?
For 1 terabyte.
That's good.
That's really good. It's Samsung. You know, you'd expect it to be a lot more premium in cost for a premium product, but no, it's
Yeah.
great.
That's the way to go. Let's do it.
So far with Intel, we can easily fit power supply on a decent case. But I think to make it fair, we're gonna get the same power supply twice here. So we're gonna go for bronze rated power supply.
Wait, bronze? That's not as good as gold or silver, right?
Gold, platinum, titanium, they're great.
That's third place, bronze.
Third place is still better than last, which is no rating.
Is this what we're talking about here?
Probably that guy, yeah.
This is 85 bucks.
85 bucks, unless I have something cheaper. We could probably even look at PowerSpec. PowerSpec is Micro Center's house brand. The one advantage PowerSpec is gonna give us in this whole thing, other than cost, is an in-house warranty of 5 years. So if your power supply does fail on you, you can just come back to us and we'll replace it.
What do you mean when? I don't want a when, I want a if.
When your power supply does fail on you, you can come back and we'll replace it for you.
Okay, all
in
right,
5 years.
that's fair. These are 80 bucks though.
Yeah.
We're not far off from the 85.
Well, hold on. 850 watt gold, 80 bucks too.
Do we really need that much power though?
No, but if we're paying the same amount of money,
That's true.
there's a good chance this might be a good bit under that in cost because these are not supposed to be the same price.
That's weird, right?
Yeah, it'd be very weird to have an 850 watt gold power supply.
I smell a deal.
I also smell a deal. And I think this build just got a whole lot easier. And as far as these two go right now, they're the same price. So we might as well go for the 850 watt.
Interesting.
Yeah.
I don't think we have enough space or enough budget for a case now.
Hold on. We can take a look at one of our last picks, which is actually Gamdias.
Shoe boxes are gonna cost more than that.
The GC1. It's an ATX case. It should fit everything, and it's only 50 bucks.
That's good. And it's rated 4.6. And it comes with all those fans?
It does. It comes with 4 fans.
That's all we need, baby. Let's do
So
it. 50 bucks. This is actually good because it's not huge. I like that.
For the cooler, we're gonna go thermal, right? You can't really go wrong with our coolers. The Phantom Spirit has a TDP rating of like 290 watts. and we don't need the fun RGB. We just need a good cooler.
So wait, those are 60 bucks a piece?
It is, but Microsoft is very good about price matching, and Thermalright is not that hard to price match.
So we're gonna price match it and get it for about 36 bucks?
About 36 bucks, 35.90, 36.90 if we want RGB, but
okay.
We're trying to save every single penny we can right
I
now.
like that. Thanks.
Only other thing you need is like operating system, but you have that taken care of.
I think we can manage the operating system, but realistically, it's gonna cost probably about 100 bucks.
Yeah, to get an official Windows license, it's about like 120 to 140 bucks for home.
Right, but if you install Linux, it's free. We picked out these individually, but it turned out it's one of the bundles that's offered.
Yeah, you save 100 bucks on the Intel one. So it's regular $549.97, but because the processor gets a discount with it, you save 100 bucks there. I think the AMD is actually even more impressive of a savings. So you're saving about 140 bucks.
So the AMD is actually cheaper.
Yeah. But what isn't cheaper with AMD was the graphics card.
And that's generally how it's been in the past,
Yeah,
right?
100%.
Intel has been always a little bit more expensive on the CPU side. On the GPU side, NVIDIA is the most expensive, then AMD, and then Intel. And if you want a whole list, there you go. You can look at the whole list, or it's also available on the website. That 9950 X3D, top of the line right there, $699. That's already 2/3 of our budget. And the cheapest one, Ryzen 5 4500, is 59 bucks for a processor. Why aren't we going with that? So we can get a beefier GPU?
Because of the fact that you're going to be limited to B550 board, which supports a max of Gen 4. It's an old platform, it's a dead platform, versus AM5, which is still alive and breathing.
Oh, gotcha. Let's count it up and check out. They're gonna do the build for me today because, well, I'm gonna go grab coffee and lunch while they're building it for me, which is one of the nice things about Micro Center, you know? And I've already built like 4 systems in the past month, so.
Maybe even more than that.
Dan, he's called the knowledge advisor for a reason. Thanks a lot, Dan, appreciate
It's
that.
fun to do videos with you, Alex.
Yes.
Plus people compliment my hair every time you do one, so.
Compliment Dan's hair.
That's right.
Nobody's doing push-ups today because
No.
I think we're right within the budget, so we're good to go.
Plus I'm sleepy.
You know what? I'll do a couple push-ups because I know you've been expecting it, so let's do a couple. 1, 2, is that enough? I think that's good.
Perfect.
I think that's good. All right.
Excellent. Best form.
Let's go. Thanks, Amin. There's one. And the other one. I don't actually know which one is which. That's the Intel one. And that's the AMD one. Let's race them. Before we get into software development tests, this is Geekbench. I'm sorry, it's a little bit loud in here. You can probably tell why. What I didn't tell you yet is which one of these on the screen is which machine. So I want you to guess right now before I show you. For a single core, we got 3076 up top and 2933 on the bottom, 19,263 multi-core score up on top, and 14,469 on the bottom. Any guesses? Write your comments down below. Up on top, we've got the 20-core Intel Ultra 7 265K. And yes, it is 20 cores. We've got 8 performance cores and 12 efficiency cores. There's no more multi-threading there. On the AMD machine, we have multiple threads, 8 cores, 16 threads. So a little bit of a different setup there. So I'm gonna kick things off with speedometer 3.1, which is a single core operation. And this is useful for web developers that are developing applications. And also you wanna be able to compare how your applications will look to the users. This is just a bunch of JavaScript applications. They're using different frameworks and so on, adding items, removing items from lists. And wow, that's actually really, really close. Another test that web developers often use is Jetstream 2. This is a JavaScript and WebAssembly test, and it focuses on the most advanced web applications. Let's kick that off. We've got TypeScript in there. We've got WSL. It tests TypeScript. I already said TypeScript. Uglify, just a whole suite of tests. Now, while that's running, it takes a little while. The speedometer test results are actually pretty good. I've seen Lunar Lake results as low as 13, and the best I've seen was about 50, 51 from the top MacBooks like the M4 Max. And here we're getting 37 and 41. And here we go, Jetstream 2, 496 on the Intel machine, 476 on the AMD machine. And this is actually also following quite nicely that single core result. Here are some tests that are relevant. TypeScript, we got 50 on the Intel machine, we got 45.6 94.6 on the AMD, Uglify JS 94.7 on the Intel, 89.3, so pretty much step in step over there. I also have a web tooling benchmark installed locally. It's available up on GitHub if you want to run this yourself. Right here, it's about 7 years ago is when it was last updated, but it's still a goodie and it's still relevant today. And it runs on modern Node. We've got Node CLI.js. I've got Node 24 here, and boom, let's go. This one tests things like Acorn, Babel, TypeScript, Uglify, things like that. Tools that web developers have been using for many years. You might not even know that you're using some of these because now you're using more abstracted frameworks that hide this stuff from you. And here we go. Prettier is 28.82 runs per second on the Intel. On the AMD, Prettier is 27.4. TypeScript 44.84 on the Intel. TypeScript 37.22. The geometric mean, that's the final score, 34.08 on the Intel machine and 29.67 on the AMD machine. So close, but the Intel wins pretty much every single test that we've thrown at it that's a web developer kind of test that's single core. Now, web development is not always single core. If you're doing back-end stuff, we're talking about multi-core, and we'll come back to that in a moment. But first, I want to change gears and do some interpreted Python tests. Specifically, this one right here. This is on Benchmark's game, and I'm talking about the Mandelbrot test. Mandelbrot is a mathematician that discovered the algorithm that fractal patterns. There's lots of different implementations on this site. I'm using the Python implementation, which is actually pretty short right there. And then you recommend I use the 16,000 parameter, which is something I've been using if you're familiar with the channel and the tests I've been doing here. To get the total time here in PowerShell, we need to use the measure command commandlet. There's no time command. I wish there was, but there isn't. I'll send the 16,000 parameter to both of these and let's go. Oh, you might be able to hear that spinning up. Yeah, it's gotten a little bit louder here. And the reason for that is this test uses all the available cores. It maxes them all out. Holy cow, that is a huge difference. The Intel machine is more than 2 times faster than the AMD machine. 13.079 seconds for this test on the Intel machine. Same exact parameters, 30.4 seconds on the AMD machine. That is a huge difference. Let's do that again. I can't believe this. Cannot believe that. That's crazy. We take a look at Task Manager. Yeah, there it is. So there's that spike on the CPU on all the cores. Okay, you can see that there it is on the AMD machine as well. The AMD machine does have less logical processors. Now, another thing that requires multiple cores is code compilation. Oh, by the way, we got pretty much the same results here. 13.1 seconds on the Intel, 30.4 seconds on the AMD. Very consistent results. Huge win for the Intel box there. I was a .NET developer for a long time, and this is a pretty large project. In fact, I called it Large Project appropriately. This is a benchmark that I actually wrote. And what it does is it generates 100,000 namespaces and classes so that the compiler has to compile all of them. And I have Visual Studio installed on here, which is a tool that .NET application developers use. When you install Visual Studio, you also get the CLI.NET tool. You can install it separately as part of the SDK. And I have version 9 here. Let's run that. Boom. Now this is gonna generate those 100,000 namespaces and classes and then compile all those. So that's gonna take a little while. And this is a pretty large project, a little bigger than most projects out there. I mean, I'd like to think so, but there's probably bigger projects out there too. And the Intel machine is done again. 71 seconds on the Intel box, 83 on the AMD machine. Not that huge a difference, but still, there is enough of a difference. If you're doing this compilation several times a day, it's eventually gonna add up. Now, it just so happens that a lot of you are interested in running large language models. And, you know, we put GPUs into these boxes for a reason. And I have LM Studio installed, which is a tool that I like to use because, well, it's very easy. You just install it, it runs, you download everything from the user interface, and it gives you a lot of control. You even have a server option to be able to run a server locally You can turn it on and off right there and be able to have an OpenAI compatible API endpoint that you can query programmatically from some code that you're writing that's going to use large language models, or you can use it as a coding assistant from your code editor like VS Code using the Continue plugin, for example. I go into a lot more detail about this for the members of the channel. By the way, if you're interested in becoming a member, there's a join button right down below, and I go into more in-depth topics and experiments with the members. Thanks for those that are members, but don't feel like you have to join. I do a lot of reviews publicly as well right here. So let's get something going here with LM Studio. This is a fresh install, and I want to quickly take a look at the settings here because that's going to be important. First, let's take a look at the runtime, and we do have Vulkan installed. So Vulkan is an API that's going to expose your GPUs to be able to run LLMs and other things that require parallel programming. If you run your LLMs on a CPU, it's going to be slow, and we might run into that issue. In fact, I got a couple models to test that out with. On the hardware tab is where we'll see most of the difference. On the Intel machine, LM Studio correctly identified Intel Arc B580 graphics card and linked it up to Vulkan. So we're going to be using the best technology out there right now for that, but we do have that 11.83 gigabyte VRAM limit that we might hit. Not ideal, especially depending on what kind of models you want to run, but we'll see. On the AMD side, we have correctly identified RX 9060 XT, also with Vulkan. So now we're going Vulkan against Vulkan. Insert your Star Trek jokes right now. Down in the comments below. I like to read your comments. Here we got 16 gigabytes of VRAM. I'm going to kick things off with a smaller size model here, and this is a relatively new model called Qwen 3 4B, and they've split this model into a thinking model and a non-thinking model because you have gigantic models. It's like carrying an encyclopedia with you all the time, right? You have to first run it through a router that's going to decide, oh, do I want to send this to a thinking query or a non-thinking query? All that takes time. If it's a larger model, it's going to run slower. I think smaller models, smaller fine-tuned models are actually the future, especially when it comes to agentic stuff, but that's for another video. These are not fine-tuned models, these are just the base models, but you can fine-tune these. We'll kick things off with Qwen 3 4B 2507. LM Studio is telling me that I can offload all 36 layers to the GPU. Let's load both of these models up and see what we get. I have a prompt here. It's a medium software architecture prompt. Design a scalable web application architecture for an e-commerce platform that needs to handle 10,000 concurrent users and so on and so on. It's 106 tokens in size. It's not huge, but it's not small either. It's a typical prompt that you probably write out by hand and not have generated or saved somewhere. Anyway, let's go. And there they go. And just visually comparing, they both look really, really good. They're looking fast. Here is the power usage, 270 on the Intel, 290 on the AMD machine. So just a little bit more power usage on the AMD machine. That's the whole system, not just the GPU, by the way. So very close over there. Let's take a look at the results. Oh, wow. 88 tokens per second on the Intel machine and 87.53 on the AMD. That's like neck and neck. Pretty much the same, within the margin of error. Now, I'm not comparing the quality of the answer, but this prompt actually generates a really nice response. It's pretty long and extensive and a lot of detail, which is kind of why I like this prompt, but I'm certainly not checking to see what it generated. I'm just comparing the speed here. So that was really close. Let's check the thinking model, and I have a feeling it's probably going to be the same. Again, it's telling me that 36 out of 36 layers is able to be offloaded, and I'm going to paste in the prompt in the exact same chat as before to kind of give it more context, even though we're only using 4,000 tokens of context total. Now you can see it thinking. Basically, it's still generating tokens. It's just different formatting, in my opinion. So I think that this is going to be just a tad bit slower on each of these machines, especially because I already included a little bit more context to start with. And visually, again, they're going really fast, both of them. Let's stop that and check it out. Yeah, 80.94 tokens per second on the Intel, 80.28 on the AMD. What? Intel is doing really well these days. That's pretty good. Now, what if I wanted to shake things up a little bit, huh? What if I wanted to use a larger context window? 50,000. Let's grab that not thinking model again, which is only a 4 billion parameter model, and it's only 2.5 gigabytes in size, so easily fitting into the GPUs of both of these. I'm gonna crank up that context length to about 50,000, just about there. And let's load that model on the Intel, and let's do that again over here on the AMD. Load model. Okay, on the Intel it loaded. On the AMD it failed. Well, that is really unfortunate. Check this out. The GPU, the Intel B580, is using 10.4 gigabytes. So even though it's a 2.5 gigabyte model, adding all that extra context is going to crank up that demand for RAM. It's hungry for it. In fact, I did a calculator, how to calculate the VRAM requirements that you need. I did a video on that a few months ago. I'll link to it down below. And the requirements for VRAM go way up if your context increases. So here we're seeing that effects of that. 10.3 out of 12 is being used right now. But we have 16 on the AMD machine. Why is it not loading at all? And it may sound like I have an answer, but I don't. The only thing I can think of is that library that we're using for AMD that's somehow not happy with the amount of context we're adding. But we do also have guardrails available in LM Studio. We can switch the guardrails. Instead of strict, we can say relaxed or balanced or off. Off says not recommended, but you know, that's what I'm here for. I'm gonna do the things that are not recommended. So yeah. Let's set that up. Turn off those guardrails. Let's load it up again, and I'm gonna give it that 50,000 context, and let's see if it loads at all or gives us any problems. 36 out of 36 layers to the GPU, and let's go. Failed to load model. Can you do 30,000? Let's try 30,000. Okay, 30,000 it loaded. Anybody know what's happening over there? Leave a comment down below so people would learn, including me. Appreciate that. Let's paste that in and run this prompt. I'm not expecting the speed difference to be different, hugely different here, but we'll see. And I'm also gonna reload that Intel machine to a 30,000 token context and run this one more time. That Intel one is just flying. Even loading the model up is really fast on the Intel box, and that, my friends, surprises me. This is my first time using an Intel discrete GPU though, so maybe I'll get a couple more in here. Some of the new ones like the B60 or the B50, I don't know when those are coming out, but soon hopefully. Let me know if you want to see videos on those. And this is very close again. 88.73 tokens on the Intel, 89.48 on the AMD. And we're gonna switch gears again to a larger model. This model is a very popular model. I don't know why, but it is. This is GPT OSS 20B by OpenAI. That's why it's popular. But is it given quality results? That's up to you to decide. What I'm here to do is to show you that this is a model that's 12 gigabytes in size on disk. Almost 12, which we're gonna run into some issues on the Intel machine, presumably, because that only has 12 gigs and then you need a little bit of room for context. So let's try to load that up. Now, LM Studio is smart enough to let me know that only 17 out of 24 layers are going to the GPU. That's what it's recommending. But am I gonna listen? Yeah. But not this time. This time I'm gonna crank it up to 24 and try to load it up. Let's see what happens here. Okay, it's going. Hey, it loaded. I can't believe it loaded. How did that load? Well, I can see that the system memory is actually a little bit higher, so I'm suspicious about that. If the system memory is higher, I'm suspecting that some of that got loaded onto the system memory. Yeah, and it's gonna run on the CPU, potentially. But we also see that the GPU RAM the VRAM is completely filled up here. So let's run a prompt here and see what happens. This is a thinking model, so it's gonna be doing some thinking initially. While that's running, it seems to be running just fine. Let's take a look at doing the same thing on the AMD box. And LM Studio is recommending to offload 23 out of 24, so very close, but we're gonna crank it up all the way and load that up and see what happens there. Hopefully this one will load and not crash on me like the other ones was crashing. And it did. It actually loaded on the AMD machine. Good. Let's run that prompt there. It's thinking, whoa, okay, that is going really freaking fast. Now the difference with this model is that this is a sparse model. So it's not loading all the parameters all at once. It's only using a subset of the parameters, making it much, much faster. So it's a 20 billion parameter model, effectively running maybe as a few billion at a time. But look how slow Intel one is compared to the AMD one. And I have a feeling that LM Studio was lying to us. Oh, and we reached the context length limit on the AMD machine and it just stopped. So I'm gonna reload that, bring up that context length to, let's say, I don't wanna go too crazy here, but let's say 30 and 24 out of 24 GPU offload. Failed to load model. But let's see how fast it was going. I'm gonna load that model again on the AMD with the 4000 token context, run it, but then I'm gonna stop it just to see how fast that thinking process is going. And it's going really fast, 91 tokens per second there. I'm gonna stop the Intel one. That's only 6.8 tokens per second. So definitely something's going on over there. It's not running fully on the GPU. I can pretty much guarantee that. And one more test I wanna run is doing just under what LM Studio recommends on both of these machines. So in other words, 16 out of 24 up there, load model, and 16 out of 24 over here as well. And this will show us what the speed kind of would be if we're running a large model partially on the CPU and partially on the GPU, but sort of equally. Now it's definitely running on the GPU. You can kind of tell, and we can even prove it by looking at the GPU. The AMD Radeon GPU is using 100% of the GPU, but it's also using the CPU, as to be expected. But we're only getting 23% utilization on the Intel Arc GPU, whereas the rest of it is going to the CPU. The CPU utilization is expected because that's where we're sending some of it, but I was hoping to see a little bit more utilization of the GPU. All right, I stopped it. That's crazy. 25.22 tokens per second on the Intel machine, 25.38 on the AMD, neck and neck. So we got some potential with the Intel GPUs. We also need a little bit more software support on the AMD side. I hope to test more Intel GPUs here, but I did recently test some new AMD GPUs, and you can see that video right over here. Thanks for watching, and I'll see you in the next one.